What we're going to do when we move into 6.6 is realize that we can multiply and divide rationals. And what we could do, just starting with the easiest thing, is we could actually simplify right off the bat. And what I'm going to show you is that you don't actually have to do 6 times 10 is 60 and 8 times 3 is 24 and then reduce from there. So what you could do is you could just rewrite 6 as 2 times 3 and 10 as 2 times 5. And on bottom, you could rewrite 8 as 2 times 2 times 2. And, well, you can't do anything with that 3. But the whole lesson to get from this is that these 2's will cancel, this 3 will cancel with this 3, and this 2 will cancel with this 2. And your best answer is simply 5 halves. But what you may have learned before is that you could have multiplied top and bottom by 12, which is essentially 2 times 3 times 2. 2 times 3 is 6 times 2 is 12. So that rule still applies, and what you want to do is just factor completely. So as I look at this next problem, and there's a lot of terms that you're going to have. That x squared minus 4 is x times x, 2 times 2. It's that difference of squares where 1 is plus and 1 is minus. Notice the multiplication. Same thing with 3x squared plus 15x. I can factor out a 3x on that. That's a greatest common factor. And then I'm left with x plus 5. So let's factor the denominator. Factors of negative 6 that add to be negative 1 would be x minus 3, x plus 2. And then over here we also have a GCF, greatest common factor of 6x. And you'd be left with x minus 2. And double check that this is right, because 6x times x is 6x squared, and 6x times negative 2 is negative 12x. But now we can go to cancel out the like things, as long as we're multiplying. X minus 2, x minus 2, x divided by x. And then the other piece, I didn't really write it, but 3 goes into 6 twice. Just think about how we can reduce from before. And then we still have an x minus 3 on bottom, and we still have an x plus 5 on top. I guess if I really wanted to, I could have rewritten 3 and rewritten the 6 as 3 times 2, and that's why the 3's go away and you're left with a 2 on bottom. So this is a good answer, but you could also have somebody rewrite it a slightly different way. And we're just doing more of the same thing. And maybe that's what I should have done in the previous lesson, is instead of, I guess, working through all of it the same way, I could just have shown you that 8 is 2 times 2 times 2. We have 7, 4, 5 y's. 10 is 2 times 5 with 2 x's. Can't do anything with that 5, but we have 3 x's. 6 is 2 times 3 with 3 y's. And I guess the fun starts after that, is start canceling out. This 2 would cancel out with this 2. This 5 could cancel out with this 5. We could cancel out 2 x's. And then we could cancel out 3 y's. And what are we left with? If I counted correctly, 2 times 2 times 2 would be 8 y to the 4th. And on bottom, you're left with 3x. You can do the same thing with the next one. But again, it might make more sense if oops, forgot my 3. 2 times 3, 2 x's, 3 y's. 10 is 2 times 5, 1x, 2 y's. And on bottom, you can do the same thing. 2 times 2, 5 x's, 2 y's. 9 is 3 times 3, 5 x's. Running out of room, 7 y's. And then start canceling. As long as you have something on top and bottom. And it's all multiplication, so we're good to do this. Then we can cancel out 2 of these x's. 1 more x cancels out over here. See, 1, 2, 3, 4, 5 y's. 1, 2, 3, 4, 5 y's. And as long as I did this correctly, I'll end up with a 5 on top. I have a 3 on the bottom with 1, 2, 3, 4, 5, 6, 7 x's and 1, 2, 3, 4 y's. And I'm going to trust that I did this correctly. So just to make it a little bit more complicated, it might be a lot more complicated, is to factor with, this is an entire expression. 2x could be factored out with x plus 6. If you look at factors of negative 12 that add to be negative 4, that would be x minus 6, x plus 2. And on bottom, I can GCF out of 4, x plus 2. And I don't know if I need to really put in these parentheses, but then we have another difference of squares, x plus 6, x minus 6. So hopefully you remember all of these tricks from before, that x plus 6 is cancel, x minus 6 is cancel, x plus 2 is cancel, and 2 divided by 4, well, 2 goes into 4 twice. So this final answer is just x over 2. Now to check your work, it would just take you a while, but what you could do is you could go into y equals and type in all of the original problem. I'm not actually going to do this. Times another one. And what you would see, let me clear that out, and then make the other fraction, x over 2. And when you go to the graph, what you'll see is that the blue curve and the red curve would fall directly on top of each other. Blue and red because of the colors I've noted. And so the next one's really the same thing. 3 minus x, 3 plus x. That's his first one. And now we have a GCF on the next one. Should be 4x, x minus 1. On bottom, we have another GCF, 2x squared, x minus 3. And then we have a x plus 3, x minus 1. Now, hopefully you're picking up on everything I'm doing, otherwise this lesson will take me forever. And this time, when we cancel certain things out, we can cancel out one of these x's. 2 goes into 4 twice, so we're going to have a 2 on top. We have an x on bottom from right there. The x plus 3 cancels out with a 3 plus x because addition's commutative. Same thing with that x minus 1 and x minus 1. But you have to remember, let me circle this bit, because they're not the same and subtraction's not commutative, but we learned in the previous lesson that that cancels out to be a negative 1. So that will be your final answer. Let me just clean that up a little bit. And that should be correct. Now you may remember from before this, a lot of students come to me and they say, keep, switch, flip. I'm not a big fan of memorizing things, but it is true. Your teacher did not lie to you. The reason why this works is when you divide by a fraction is the same as multiplying by the reciprocal. Dividing by a fraction is the same as multiplying by the reciprocal. So your teacher that taught you keep, switch, flip was not lying. It's just, I would rather write it this way. Maybe while I'm at it, I can also factor. Like 15 is the same thing as 3 times 5 with 2 x's. 6 is 2 times 3 with 5 y's. Hopefully I'm reading that correctly. And you switch that division to be a multiplication, and so what was on the bottom now is on top. And then what was on top is now on bottom. 1, 2, 3, 4, 5, 6, 7, 8. And now you can cancel just like you did before. So division and multiplication are pretty much the same. 3's will cancel, these 5's will cancel. We have 2 x's on top, 2 x's on bottom. That leaves me with 6 x's on bottom. And what do we got? 1, 2, 3, 4, 5 y's on bottom. 1, 2, 3, 4, 5 y's on top. Leaving me with 2 y's on top. And yeah, when you get practice though, you might not break it all the way down. For instance, 30 and 20, you might just look at that and say, well, 10 goes into both. 1, 2, 3, 4, 5, 6. 2 times 10 with 3 x's. But then remember, you have to change that multiplication. So you might not actually break down the 8. because you know that 24 is the same thing as 8 times 3 with 2 y's. But now you can simplify, just like what we talked about. I guess I didn't really emphasize the multiply by the reciprocal, the keep, switch, flip, but I definitely did that over here. 3's will cancel, 8's will cancel, 1x will cancel, and 2 y's cancel. And when that's all said and done, you're left with 4 y's on top with 2x squared on bottom. All right, so then really the same thing in the next one. You're just going to have to get practice with factoring. X plus 4, x minus 2. That's this top piece. I got a GCF on bottom. That's an 8, x minus 2. Switch that division to be multiplication. Keep, switch. And not only am I going to flip these two, I'm also going to factor while I'm at it. 2 goes into both 2 and 10, x plus 5. And then I also have a difference of squares. X plus 4, x minus 4. And hopefully things cancel. X plus 4, x minus 2. Let's see, 2 goes into 8 4 times. So I have 4 with an x minus 4. And I still have x plus 5 on top. And just so you know, there are other ways of writing these answers. I just like to leave my answers like this. Just moving on to the next one. I'm really doing the same thing over and over again. Difference of squares. Ooh, we have a slide and divide on this one. That 3 times 2 is 6. Factors of 6 are to be 7. And then divide. Just don't forget to reduce as well as slide back. 3x plus 1 and then x plus 2. We got to switch that to a multiplication. I'm going to put that 5 on the bottom, 1 minus 3x. And then on the bottom piece, which is now on top now, factors out as x minus 7, x plus 2. So as I go to cancel out, x plus 2's cancel. Let's see, 3x plus 1 cancels. These things are not quite the same, but remember that if they're the opposite, 3x minus 1 versus 1 minus 3x, they do cancel with a negative brought in front. The negative of x minus 7 over 5. All right, and then again, there's other ways of writing that. So the reason why keep, switch, flip actually works is based off of the next example. So I'm going to write it kind of the old school way when you're dividing, to write it like this. So if you're fine with memorizing the keep, switch, flip, let me just explain real quick why that works. Is because you want to get rid of a denominator, and the only way to get rid of it is to multiply by the reciprocal. Well, you can't just multiply the denominator by that unless you also multiply the numerator by the same thing. And that cancels the x plus 5, that cancels the 9x. And now it's just the same problem that we've been working on. Well, if you look in the numerator, we have another difference of squares. Times, maybe change 9 to be 3 times x. And then you have the 3x with an x plus 5. And at this point, I think you can see the x plus 5's cancel, 3's cancel, and an x cancels. And none of my answers match. However, I can distribute this 3 into this problem, and I get 3x minus 15, which is the correct answer. So you should be ready for the homework at this point.